Yes, dear students, now today I am going to tell you very important topic and very important chapter of physics, that is magnetic effect of current. That is magnetic effect of current. So in fact, we have learned in class 9 and 10 also about magnet, about current, electric current, and I have told lot of things about electric current. Electricity and magnetism both were known more than 2000 years ago. What I am telling? Magnetism and electricity both were known more than 2000 years ago. Since a long time, but they were treated different field of physics. There was no relation. It is in 1820. In 1820, during an experiment, Oersted, discovered that when we pass electric current through a conductor, magnetically produced, the circular path here shows the path followed by a compass needle. Compass छोटी magnet होती है, and that follow this path, and these are called field lines. The arrow gives the direction. Actually here what is this? It is a simple plain board which is horizontal. Conductor carry current vertically up, like this conductor, this plain board is parallel to table. Suppose it is placed on table and current is coming out of the table. Current is coming out of the table. So he noticed that when we pass current through the conductor, a magnetic field is produced around it. Conductor carrying upward or downward भी होता है, but field is in horizontal plane. If we carry the current horizontally, then field will be in vertical plane, like this or like this, depending on the direction of current. Here this figure shows a battery, and from this battery current I is flowing through this conductor, which is normal to this board. It is simply a white paper placed on board, and current is passing normally. By memory, actually I have drawn these arrows are put by my memory, I know. Then there is a law to find the direction. Here I have drawn this figure, a conductor which is holding my right hand like this. The right hand. This is thumb stretched along the direction of current. The curl of fingers gives the direction of magnetic field. So this is a qualitative idea about the magnetic field produced by a current carrying conductor. The direction of field produced depend on direction of current, and value यानी कि magnitude of field will depend on current, and there are different configuration by which we produce magnetic field. A lot of number of things are there, which are used to produce magnetic field. We learn. The chapter is a little lengthy and require basic knowledge of some mathematics and mechanics also. In previous video I told you to learn scalar product and vector product of vectors. I have posted a video regarding vectors. There is a playlist about vector. Please, before reading this chapter, look into those topics which I have given in the videos which are posted in playlist of vector and scalar. Heading है scalar and vector के नाम से, है ना? There is a playlist in which I have described what are vectors, because now you are in class 12. This topic of class 12. One student asked me which class you are teaching. So naturally, you know the syllabus. It is class 12 topic. So please be sincere, and before learning this chapter, please learn vector product, scalar product carefully. Try to understand what is scalar product, what is vector product, and why we are learning them. हम उनको पढ़ क्यों रहे हैं, ये भी पता होना चाहिए हमें. Most important chapter, these are 4 chapters which are mutually coupled with each other. If you don't know this chapter, then you can't understand next chapter. And if you don't know these 2 chapters, third, electromagnetic induction cannot be understood. And if you do not know what is electroinduction, you cannot learn about alternating current and then EM wave. These chapters require a lot of labor and understanding and cramming also. Nowadays students do not cram. Just now I met a student who was unable to tell his subject in class 12. I was very much worried. He was class 12 pass student and he was unable to write his name, etc. Please, आप सब ऐसे तो नहीं होंगे, तो take interest and write yourself. Don't look only the video. Prepare the notes yourself. Take the help of books. Take the help of video, and your own brain. Apply your own brain. Unless you apply your brain, you will not learn anything. So here I told you qualitatively what is magnetic current means. When we pass electric current through a conductor, a magnetic field is produced around the conductor. This effect of current is called magnetic effect. It was simple experiment demonstrate that when we pass current, a circular field lines are produced around the conductor. The direction is known by right hand thumb rule. Here right hand, this is simple rule, right hand thumb rule. Thumb rule. I am telling it because of the introduction. This is not ultimate rule. I will tell you a basic law which will be telling you the magnitude direction both. So now I want to discuss you here and tell you about which law, basic law is there, which determines the magnitude direction of current carrying conductor. And that law is Biot-Savart law. B-I-O-T, Biot. T silent है, Biot-Savart law. Savart law. Actually, in different books, this has been described very wrongly. Now, people are trying, they have modified their own, the books which I read many times. They have now modified their version about this law. This law gives the magnitude and direction of magnetic field produced by a small length of current carrying conductor, small length. Suppose it is long conductor here, carrying current I this way. This element is length, ये length dl है और इसको हम idl लिखते हैं. Direction of dl means direction flow positive charging, direction of current, but we mark arrow on dl. I write little longer. It is point P here. This is point P. This is position vector R. This is angle theta between the direction of current here. But don't confuse that What I write it for the whole length. The magnetic field due to this length only is given by Biot-Savart law. Biot-Savart law gives the magnitude and direction of magnetic field produced by small length dl at any point P. And according to this law, according to this law, magnetic field due to small length, small means in comparison to whole length, this length is negligibly small length element dl. I write here vector dl. According to this law, magnetic field due to small length element dl of conductor carrying current I at any point whose position vector is r with respect to dl is given by, I request you to learn the same manner. Is given by, what is that? Vector dB is equal to mu 0 upon 4 pi into I vector dl cross vector r upon modulus r cube. Basically, this is Biot-Savart law. Have we? Vector dB. Vector dB here. Vector dB here is equal to mu 0 upon 4 pi I dl cross r upon modulus r cube. Modulus r cube. So now, what is the meaning of this sentence? I write here again, vector dB equal to mu 0 upon 4 pi I dl cross r upon modulus r cube. Vector dB, it means direction is there. तो डायरेक्शन ऑफ वेक्टर dB क्या होगा? What is the direction of dl cross r? In previous video, I asked you to learn direction of vector product. I told you direction dl cross r will be determined using right hand screw rule, and direction vector dB or vector dl cross r will be at right angle to the plane containing vector dl and r. Here, if vector dl and r lying in the plane of board, you will say in the plane of paper. Then dl cross r, screw is rotating clockwise, and if it is clockwise, then normal to plane of board and into it, which we show by cross. Here this cross means vector dB is normal to plane of board. I will write board. Normal to plane of board and into it. You have to understand this topic, otherwise you will be in trouble in this chapter. Direction of vector dB is along vector dl cross r. dl has direction this, along current. R is this, so dl cross r. I told you A cross B. I am explaining again, this is vector A, this is vector B. So A cross B. A cross B, I told you, will have direction normal to plane containing vector A and B, and that is planar board. And A cross B rotate like this, so A cross B this way. Normal to A and B both. If I do B cross A, it is A, it is B. तो ये clockwise होगा, तो it will be downward. B cross A. Please don't speak B गुणा A. B multiplied by A नहीं है. Don't speak B multiplied by A. It is B cross A. We are here using vector, है ना? तो vector product B cross A. It is A cross B. तो अगर if I take point P dash here, then it is into, then it outward, sorry. Dot means outward. So direction will be determined from this law. Vector product of dl cross r. Magnitude A cross B. Magnitude will be modulus A, modulus B, sin theta. So here dl vector dB magnitude क्या होगा? dB is equal modulus equal to mu 0.4 pi I dl r sin 90 sin theta, sorry, sin theta upon r cube. modulus तो कैंसिल हो जाएंगे, mu 0.4 pi I dl sin theta upon r square. Actually, many authors don't tell vector dB this way. And many teachers even I have seen don't do this. They write B proportional to I, B proportional to L. L is the whole length, which is totally wrong. It is the field, Biot-Savart law gives the magnetic field due to small length of current carrying, not the whole length. I think you have got my point. So magnitude is this, right? dB magnitude. Now you might be thinking, what is mu 0? Mu 0 is called magnetic permeability of vacuum. See the spelling vacuum. Generally, I have seen the spelling of vacuum very wrong. VACWM, not double C, vacuum. Some people speak at vacuum, and its value is 4 pi into 10 to the power minus 7 SI unit, minus 7 SI unit. I will tell you later on. Permeability means ability to permit the magnetic field to pass through the medium. You might have in chemistry osmosis, semi-permeable membrane, जिसमें से आर पार कुछ molecule pass हो जाते हैं, तो that is called permeable. So a field line can pass, how to what extent the medium allow the field line to pass. There are materials which do not allow the field to pass. So that is permeability. So it is about Biot-Savart law. Now in next coming videos we will be using Biot-Savart law application. So please take it very serious. This is very important, basic fundamental of magnetism, like Newton line mechanics is very fundamental. So thank you.